People point to those. They say, well, I did these tested inspections and it broke. We've never touched this stuff over here and it runs fine. So, again, why should I do maintenance? It's like the guy who never changes the oil in his car. It's run for 12,000 miles and he's never changed the oil, and it's still kicking. So.
Hey, and welcome to the Electrical Safety Podcast. I'm your host, John Travis, and today I've got Stephen Hester joining us for the second time. Stephen, good to see you again.
Good to be back.
Yeah. So I noticed an announcement a little while ago and thought I'd reach out and kind of see, you've kind of gone out on your own now with a new business, and just curious, maybe if you want to give us a little bit of the background on that and what you're trying to do.
Yeah, well, back in earlier this year, I started my LLC. It's Regenschirm, which Regenschirm is a German word, means umbrella. And I just, not really any real significance to that. I just kind of picked it because I knew that nobody else was going to have a name like that. But Regenschirm Training and Consulting LLC, and I'm doing pretty much the same thing that I've been doing all along, and specializing in electrical safety training, electrical technical skills. So I still do, testing and maintenance training. But I wanted to branch out there too and do more consulting on the safety side, electrical safety side, do more reliability consulting, as well as being able to go out there and teach some additional classes that, in the past, I've wanted to do, but couldn't necessarily get the support from an employer to do that. So leadership and management training and EHS risk management are also part of the program there too. And I'm sure as I go along, there'll be other offerings, but I just felt like I wanted to go out there and be free from what a corporate employer wanted me to do, and be able to help my customers in the way that I best be fit to do that. So,
yeah. So I'm kind of curious on you mentioned start with the maintenance, reliability, consulting. This is something that I feel like, and let's just think about maybe the manufacturing world. They have a hard time with this, especially in the electrical, because, most of the people that I've talked to, they're basically just fixing things that are broken.
Right.
And they never have time to even think about planning or any of that stuff. What does it look like when you go in and maybe start working with somebody? Like, what are the types of maintenance you're even focused on? What are some of the challenges they're facing? Just what's that whole consulting piece look like, I guess?
Well, one of the first things that, the clients are faced with, the first challenges that they face when it comes to maintenance, of course, is always money. It always comes back to money and manpower. So a principal complaint is, we just don't have the money, or we don't have the people to take care of everything that we need. And unfortunately, you can see this in new facilities where their equipment may have not been installed or commissioned properly. So you see them having problems from day one. Then of course, again, like I said, it always comes back to money. So production is an issue too. And you've got maintenance managers who see the need to take an outage to perform maintenance. You got plant managers who don't share the same sentiment. So even when they have the resources available, sometimes just finding the time is a challenge too. Of course, a lot of them have questions about what kind of tests and inspections they really should be doing, or what kind of results they should see. So when I'm out there doing training, doing consulting, that's one thing I'm really talking about, is what kind of tests and inspections would be recommended by NETA, would be recommended by the NFPA 70B, what's recommended by the manufacturer, and what kind of results they should see, as well as how often they should be doing that. So part of it is commiserating with them, because I get the resource part, but also helping them maximize the use of those resources when they have them.
Hmm. So that's something that, like, for me, I've thought about this before. So let's say you go into, if it doesn't matter if it's new or not, they've got a number of different types of equipment. And when you look at NETA standards, or when you look at NFPA 70B, it might seem overwhelming to somebody as to how much stuff is recommended in there to do.
Right.
How do you kind of narrow that down so you can say, all right, let's start here. Like, how can you figure out what's the most important stuff to do?
Well, in the first places always go to are the manufacturer's recommendations. But granted, some manufacturers don't have very well-defined expectations for how to maintain their equipment, but that's usually the first place we'll go. And then we'll look at what the manufacturer recommends and then compare that to the recommendations in the NETA and the 70B. You've still got a lot of people out there who want to power factor test circuit breakers, which really you can power factor test anything just about, but it's not really a necessary test on some equipment. Or they want to go out there and they want to do secondary injection testing on all their low voltage breakers when they should be doing primary injection testing. So sometimes it's a challenge to get them to see through the industry consensus standards as far as what they should be doing and how often, and get them to realize that 70B is, even though it says standard for equipment maintenance, it's still a recommendation, and ultimately they have to decide what's best for their equipment. So that can be a challenge, and looking at their environment too. If they're on the Gulf Coast, they're going to have maintenance challenges that somebody out in West Texas is not going to see. So that can be a struggle, but we start off with the recommendations and work from there.
Okay, so this would be for that. You mentioned like the operations manager that doesn't want to shut down, or maybe it's a general manager and they just can't see. Because I can kind of think of, like, I don't know, just take human health, for example. There's all kinds of recommendations out there. There's all kinds of things you can do, and tests you can take, and pills, and all sorts of stuff. And you look at it, it's like, where do I begin? Or does any of this even work? Because I know, so-and-so down the road, he's smoked his entire life and he seems fine. And so how do you, is there any numbers out there that you can share with people, or is there information that shows, like, here, if you put this much into maintenance every year, you're going to get this kind of return on uptime? Or that's what's always been what I find the challenge when we're talking to people about this stuff.
Right. I mean, we look at 80/20 is always a good number that people like to throw out there. And say 80% of your problems are caused by 20% of your equipment. And we know out there, and it varies from plant to plant, of course, but you've got a magical crossover point at which I guess you call it an operating envelope, where your equipment is going to run fine. And after a certain number of hours, you kind of hit that, the reliability curve is coming down, and the run hour curve is going up. So they're going to cross over. And it's hard to say what that's going to be with individual types of gear. And I know there's numbers out there right now. I can't quote them right off the top of my head. So I wouldn't even want to try without looking all that up. But, companies like EPRI, insurance companies, I think, another one I'm trying to think of, have done, I've done research studies on this, and can give us an idea of what your reliability would look like over time with, based on your maintenance expenditures. The problem is, we can't say that equipment that's perfectly maintained, and I don't even know what that is, will not fail because you might say, well, I did everything that the manufacturer suggested and it still broke. Uh, Likewise, we can't say that doing nothing will cause it to fail because we see equipment out there that just looks like it's never been maintained and probably hasn't been, that has run fine for 50 years. So,
Hmm.
people point to those. They say, well, I did these tests and inspections and it broke. Um, we've never touched this stuff over here and it runs fine. So, again, why should I do maintenance? Um, and that's another challenge too, because even when you show them the numbers, they're going to look to their own experience and say, well, we don't put any maintenance money into our stuff and we don't have any problems. So why should I start now? It's like the guy who never changes the oil in his car.
Yeah,
It's run for 12,000 miles and he's never changed the oil, and it's still kicking. So my
I
luck,
know.
yeah, it die.
We talked a bit about training last time, um, but I'm curious. Once you get kind of past the basic electrical safety stuff, and I think you do a bit more, maybe would you call it maintenance training or like technical training with
uh,
electricians?
yeah, maintenance training. So I'm teaching them, um, how basic tests and inspections work. A lot of plant electricians, one of the first things they'll tell me is, well, we don't do these tests. That's what we hire so and so to come in and do.
Right.
But one thing I emphasize is that they need to understand how these tests and inspections are performed and what kind of results they should see. Because otherwise, when they're looking at a test report, they don't necessarily know if it's right or not, or even if the test is being performed correctly. They just see somebody doing it. So the more I can teach them about how the tests work, I think the better prepared they're going to be when their contractor comes in to do the maintenance, rather than them just saying, "Okay, hey, you guys hit it, and tell us what you found." They're going to have a frame of reference now for looking at the test at the inspection, looking at the test being performed, looking at the inspection report, the test report, and making a intelligent determination of whether that is good or not. So, because I've
Yeah.
seen plenty of test reports out there that have been handed to the customer and they're not correct.
Hmm.
Um, and the customer may not recognize that. So, where there's things that that should be on the test report, that were not there. And I'm a big believer in the more information you give the client, the better. And that's one of the things I always preach.
Yeah. So, I mean, that's a problem. Like, I can definitely see with a lot of organizations, and maybe you can, is that you've got maybe a management team that doesn't have anybody with an electrical background on the management side.
Mm,
Then you might not even have electrical workers within the company. They might be considered maintenance techs, and maybe they did a little bit of electrical here and there. Um, you've got these people who are managing the maintenance for for whatever manufacturing facility, whatever it is. And so they don't even really get not only like the specifics of that technical thing that you're doing, but they don't even understand, even from a broad view, like why are we even doing some of this stuff.
right.
I mean, if you had to kind of go into a situation like that, um, you know, just very basic, what would you tell that organization that the benefits of this maintenance and planning and all that are going to be?
No, you go in there and you're right. You've got guys in there who maybe at a plant, there might be a state licensed master electrician. That doesn't mean they know anything about switchgear, because the NEC, the code exam, is going to quiz you on your knowledge of the code. It's not going to quiz you on your knowledge of maintenance and testing. So you go in there and talk about um, what the test is designed to measure. What are we looking at on a test? What part of the equipment is it actually evaluating, like insulation resistance? You got guys out there that think that insulation is good. If it doesn't look deteriorated, then obviously it must be good. So uh, we talk about the basics of insulation resistance monitoring, how we can detect breakdown in the insulation before it becomes visible, how we can see deterioration in, say, for example, circuit breaker contacts, um, cables, of course, cable insulation, that's a big one, cable diagnostics, transformer oil, you can't see that. So really one of the primary indicators of transformer condition is going to be the testing that you do on it, whether it's online or offline testing. Just depends on what you can do. But it's like doing a power factor test to determine the condition of oil. Doing your oil testing,
Hmm.
um, those have to go hand in hand. So when they say, well, we just want a power factor test a transformer, or we want to do oil tests on it, it's more than that. You've got to get a complete picture of what piece of equipment looks like, and then trend that information so that now we can see which way. It's not getting any better with age, most likely. I mean, it's going to deteriorate over time, and we see how fast that is. And that's one thing you want to tell them, so they understand that just because I got a good picture of it today, um, that doesn't mean that it's going to be good forever. And where is it at? Is it really really good, or is it right on the margin? And then what does that mean? Well, it's still good, but how good and how long is it going to last at this point? So
Hmm.
and those are challenges too. So well, it's still good. Maybe by 1 part per million of dissolved gases, but uh, so well, it's or it barely hits its dielectric breakdown threshold. So it's not bad, but we know it's pretty close to being bad. So now what does that customer really need to do?
Right. So now, okay. So let's imagine you start doing this maintenance testing. You've got some frequency. So
Mhm.
is the hopes is that you're catching things before they happen,
Absolutely.
and you're okay. And then that's how you're saving money in the long run
Yeah,
because now you don't have to
absolutely.
break
The
down.
idea there is, predictive. Of course, predictive is going to go hand in hand with preventive, because if you can see it coming, then you can stave off that, hopefully. Um, in some cases, and I tell my customers, look, in some cases, reactive maintenance is just fine. If something smokes, you pull it out, you replace it, you throw the old one in the scrap metal bin. It's easy. Um, there are some things out there, though, that they are big and they are expensive and they are difficult to replace.
Mm,
And that's why maintenance becomes more important, because if you've got some unique piece of equipment that is going to be difficult to replace, it has a long lead time, and it's very expensive, that just increases the need for maintenance on that thing, and testing
right.
on it to see where it's at. Otherwise, who wants to do power factor testing? Who wants to do a lot of maintenance testing on a fractional horsepower motor? It's just it's not that
So
not that big of a
okay. So
deal.
that might have been kind of what I was trying to get at earlier. Um, when I was thinking like, how do you narrow down what to focus on? So yeah, and I don't know the answer to this, but like in the NETA standards or in 70B, they probably just focus on all of the recommended maintenance for every single thing there is, but they don't say, oh, by the way, this type of equipment is very expensive. This one is very
Mhm.
hard to change. This one. So maybe that's what you can help the clients with figure out a bit more
Right. Well, if
is
you look in the back of the MTS, for example, there's a frequency matrix back there, and it's based on the reliability requirement and the material condition of the equipment. So, if it was something that has a high reliability requirement and is in excellent condition, then you wouldn't test and inspect it as often. If it's a high reliability requirement, but it's a piece of junk, then your tests and inspections will be a lot more frequent. And as a matter of fact, you may be looking, instead of monthly inspection intervals, you might be looking at weeks, based
Okay.
on that reliability and equipment condition. If it's a
So,
low reliability requirement and it's garbage, it's probably going to burn up, and you've got another one in the stock room.
and what does that exactly mean? So high reliability requirement means,
Something that your process cannot survive without. It would cause
okay.
you an unplanned outage that would result in a lot of downtime or
So we had
expensive downtime.
when I worked in the mining world, we had one facility that had two transformers, and the feeds to the site came through the same tunnel or something like that, and something happened to that tunnel, so everything was down. We had no redundancy, so basically that tunnel and the cables through it, we're saying that's a high reliability, because those, if something happens to those,
Yeah.
everything's
So yes, in that case, that's not it's not an electrical problem with the tunnel, but the failure of that tunnel did cause an electrical issue,
right.
or it could
So I
cause.
mean, yeah,
Well,
maybe
like
that wasn't that.
another client that I had, they had a piece of equipment that was a structure. It had structural failure, so the whole thing just collapsed. And when it did that, it wiped out a couple of MCC rooms. It wiped out some transformers. And so just the failure of this structural component resulted in a very expensive equipment replacement and the loss of some productivity. So that was something that, it wasn't an electrical problem per se, but it did influence their electrical distribution because it wiped out a lot of equipment when it failed. And they got very lucky in that the failure happened at a time when there was nobody around, because they would have had some serious injuries or fatalities in the process. So sometimes we have to look at things that may not be of of significance electrically with our equipment, but could become significant if they were to malfunction, or if they were just collapse completely. So really, at risk of using an overused term like holistic, that's pretty much what it becomes. When you're looking at maintenance, is not just how well does a motor shaft turn, or how well is my MCC buckets, are they clean? Is insulation quality good? But what else is there about the environment or about the other structures, equipment in the area that could influence that? So that's the one thing I always stress, is look at the rest of the environment.
Yeah.
That's
good. So are you also helping people with their electrical safety programs, procedures,
Yeah.
policies, those things?
Yeah. There is I think, as we see a growing emphasis on electrical safety programs, and it's never going to go away. We got to emphasize that you've got to have a good electrical safety program. And so, customers want help with writing policies and procedures. They want some external eyes sometimes on just what they're doing, to give them a sanity check. If they're performing a given task in a certain way, they want to know if it makes sense to do that, or is there something that they should be doing that they're not, or is there something that they are doing that they probably shouldn't be? Because sometimes you'll see customers wearing 40 cal arc flash suits where 40 cal is not necessary, or they're wearing 8 cal where they probably should have something more significant, but they might not have had a current arc flash study. So
Great.
another question: are arc flash studies really required? OSHA doesn't tell you here in the US, OSHA doesn't tell you that you have to have one, but it does tell you that you have to evaluate the hazards and communicate that information to your employees. So
Mhm.
that's something that they're interested in too. Um, so yeah, there's definitely a need for safety consulting out there, and sometimes it's just having that extra set of eyes to tell them if they're on the right track.
Yeah. So back, I got to, I mean, that one comes up a lot. People ask whether or not the arc flash studies are required. And that's, my answer is always, well, it doesn't come out and say yes or no, black and white, but it says you need to evaluate the hazards. And my next question is always, well, how are you going to do that? And I know there are other methods. Have you seen, or just kind of what's your feeling on that? Like people who choose to go the other route, can they do it successfully? Do they do it successfully, or are they just kind of,
That's
you know,
that's a objectively that's probably a difficult assessment to make. Subjectively, I'm absolutely in favor of engineered art class studies um, by a company that has demonstrated expertise in how to do that. You've got the tables in the NFPA 70E. The more I teach this, the less I like them.
mm-hmm,
So I tend to stay away from them. I'll answer customers' questions if they want. I'll go out there and teach them how to use the tables if they want. But to me, I would really rather see them go through the process of a full art class study. Well, those are expensive. Yeah, they are, but you're going to get a much better product. And I think the likelihood of um, misinterpreting what the tables are telling you or misusing the tables uh, are it. I just think if you leave it up to technicians, and it's not that technicians are smart enough to do it, they just don't have the experience in the vast majority of cases. Or if you have a plant engineer who may be a double E, but he may not have any experience with art flash calculations. So there you've got somebody who doing them who may not be really competent to do that. So
mm-hmm,
that, and I like the fact that with an external study, you have an independent third party who is going to evaluate your equipment. They're going to evaluate the condition of maintenance. They're gonna look at the numbers objectively, and they're going to give you an assessment based on what's really there versus maybe what you might want to see. Gosh, I really don't want people to be in 40 cal. So let me massage your numbers a little bit to get something else. And I've seen that
right.
happen with with using tables. Well, I don't want to wear 40. I don't want to wear 40 cal today. So let me use this. Let me use these numbers right here. And okay, well that comes out to category 2. I like that a lot better.
Yeah.
Um,
So that was kind of, I mean, that was something you said earlier on, you know, with the advantage to doing the study is like, the number. So therefore, maybe all you require is 8 calories. But, in this case, you didn't do the study. So now the guy's wearing a 40 cal suit or vice versa. Somehow you're wearing the wrong thing.
mhm.
Um, and why I'm asking this is we've got people we've come across that they they're like a contract organization and they're working at many different sites, maybe all over North America. So they never know what they're getting into,
Right.
and they never know if the client has done the arc flash study, or so they kind of have to. They're almost forced to use the tables because there's really no other way. And then what ends up happening is that they're oftentimes um, at that 40 calorie level. And so then they just say, well, you know what? Anytime we're doing any of this work, we're going to wear 40 calories. And I guess what are the downsides to that approach, if you see any?
Well, it's easy to say that it's better to be overprotected than underprotected. And that's not always the case. You've got to look at other factors too, environmental factors, um, where heavier arc flash PPE could be detrimental to the person wearing it. And when and at a certain point, I think you're just guessing, really, um, because who's going to take the time really um, to determine the condition of maintenance. And if you're out there working on something, you're out there troubleshooting, you already know that the equipment has a problem. That's the whole reason that you're there. So, now is it potentially an abnormal operating condition, and you don't know how that's going to affect you. So I just think there's a lot of variables in there where having an arc flash label, now you come back and say, well, if it's an abnormal operating condition, the equipment has some kind of deficiency, your arc flash label may not be accurate anyway, which is something that we're always going to run into, I think. And there we have to make intelligent decisions about how to approach it. But I just think that technician shows up on the job, no arc flash study, customer really doesn't have an idea of what the situation is, doesn't have a real solid PPE requirement. Technician has to make a decision on the fly. Just too many places for things to go wrong in my mind. Now, other people are going to disagree with me, and that's fine. But I just think that reliance on the tables is, and you say, well, we don't have any other way to do it. Oh, okay, I get that. As part of your risk assessment.
What I was getting at, and this is something that I've seen multiple times now. It's almost worse. It's like they're saying, well, arc flash studies are too hard. Table method is almost always comes out to 40. So we're just going to wear 40 for everything. So they're not doing anything. They're just going and putting on.
Right. And I've seen that. I had a client one time, and they asked, well, what's the highest arc flash hazard that you have in your plant? And they said, well, we've got 40 cal arc flash suits. So obviously our arc flash hazard isn't any higher than that. How do you know? Well, that's what the company gave us. They gave us 40 cal suits. So, obviously our hazard's not any higher than that, or they would have given us something else. What is that information based on? Was it based on a study, or was it just based on somebody guessing? And, we really don't know. Okay, well, now you don't have any real idea of what your arc flash hazards are. You could be well overprotected. You could be grossly underprotected. But at this point, you have no idea.
Yeah. And that's sort of what I was getting at was, if it's just a blanket rule, not only do they not know why that number was chosen, oftentimes I find they don't even truly know why they're wearing it in the first place.
Right.
So then they might be wearing it when they don't even need it at all.
And that's very true. And I've seen that happen where, well, it's a 200, it's 208, or it's 240, or it's 480. Okay, well, we all know that arc flash hazards can be dramatically different, even at the same voltage level. Just because it's 480 doesn't mean it's automatically catastrophic in terms of arc flash, and it may be very, very low. But they're looking at it and say, and again, I had another client one time. They said, well, this is all of our 480 gear. All of our 480 volt gear is category 2. Okay, great. How'd you make that determination? Well, it's 480. 480 is automatically is going to be category 2. Okay. No. What about your 2400, 4160? Where is that at? Oh, that's all category 4 because it's higher voltage. No, That's not how this works. So really, they were just swagging it based on a complete misunderstanding of arc flash studies, and so you see a lot of that based on misinformation, lack of understanding. And now we've got too much PPE, not enough PPE, no PPE. Uh, and, still as long as we've been talking about art flash studies in the field, there's still a lot of misunderstanding about how art flash really works.
Mm-hmm.
And that's something that, I address on a regular basis. Another example of that, in a customer's facility, and I was talking to operators. I do a lot of operator training, and we were talking about art flash labels. And one of the operators, they had a lot of good questions, and so I was answering their questions. We were having a good discussion, and one of the operators spoke up and he said, "I've been here for 20 years," and he said, "This was the first time that anybody has ever explained what any of this information actually means." So they had the art flash, and obviously they didn't have them for 20
Mm-hmm.
years because I don't think anybody had art flash labels 20 years ago that I can remember. But um, the time that they had art flash labels, nobody ever actually told them what that information meant and how to use it. So they were just out there uh, flying blind, and that was the wrong approach too. So I guess that's probably the second uh, the second part of that. Yeah, we've got to do the art class studies, absolutely, but we got to teach people how to use this information.
Yeah. Yeah. So let's just do a bit of a recap here. So we got the electrical safety program helping people with that, maybe some maintenance program, reliability, electrical safety training, a little bit of training on the maintenance side, the technical side, operators. Is there anything else you got going on or that you've been focused on?
Well, I'm developing leadership and management training too, because one of the questions I got asked by um, a customer recently came back to just that. It came back to leadership, and they're talking about turnover and uh, just turnover in the industry. And what uh, one of my I don't remember the exact question, but my response basically, this comes down to leadership and management too. You can pay, you can provide the best pay and benefits out there in the business, but when your technicians feel like they're being mismanaged or micromanaged or just jerked around because, well, we pay our guys really well and we have high expectations. Well, if they feel like they're being jerked around, um, that's not going to work.
Mm,
And they're going to find someplace else. It maybe doesn't pay as well, but they're going to get treated better too. So, and it's one thing I've noticed over the years. Um, and then when I ask customers about leadership and management training, they're like, "No, we've never had any of that." And well, so some of them don't believe in it, but there's a lot of them
yeah.
who do. So I think, not only plus technicians. When technicians move up to a managerial, to a supervisory position, we can't just expect them to be technicians in a supervisory position. We've got to teach them how to manage and lead people.
Yeah.
And we need that at all levels. So not just in field services, but any kind of business out there. So that's always been a passion of mine, and that's something I'm working on right now. Um,
Is it kind of tied into the electrical world, or is it just a
Well, I can tie
separate
it into the
portion?
electrical world because certainly where we're doing electrical safety training, um, supervisors, managers at all levels need to understand the management aspects of teaching NFPA 70E, NFPA 70B. So, how do they approach those subjects as managers, as supervisory personnel? Of course, obviously that's not going to be needed elsewhere. The nice thing about management and leadership principles is they're pretty much applicable in any business. Um,
Mm-hmm.
we can tie those to electrical maintenance and testing and safety and that kind of stuff as we need to, but we could tie that to fall protection or confined space or aviation safety or maritime safety or whatever the case may be. So
Yeah.
that's really something that I believe in. I'm also putting together an EHS risk management class, because, as I go out and I teach electrical safety, I tell people, hey, this is all really, it's a big risk management exercise. How do we identify hazards? How do we evaluate those hazards, determine what risk is? And that's, that's a big one, because that is so subjective many times. And then successfully mitigate that risk. And not everybody approaches that the same way. So sometimes it's just, oh, I got arc flash as a hazard, so here, let me just throw on some arc flash gear and I'm good. That's not risk management. That's wishful thinking. That's not risk. But I also tell people too, part of their day-to-day operations, to let their risk assessment be their guide, really, because they can't just blindly follow procedures. They've got to have an idea of what that risk really is and how to address that. And that's a challenging one.
If you do understand it and truly understand it, then at some point you don't need the procedures.
Well, right? That's why I've always approached. That's why I've always approached electrical safety training. Some people, when they teach NFPA 70E, it's all about the rules. For me, the rules are absolutely part of it, and I want them to know what the guidelines are within the 70E. But if you don't understand the principles, then the safe work practices are not going to make any sense.
Yeah.
You're going to know what to do, but you're not going to know why you're doing it. So
that's back to the 40 cal suit, wearing the 40 cal suit, because that's the rule.
Right.
If you don't understand how you got in that 40 cal suit and why, then if anything changes, you don't know what you're doing.
Or you've got to wear rubber insulating gloves, but your rubber insulating gloves haven't been dielectrically tested in 11 years. Well, I've got my rubber gloves. Well, yeah, you might as well be working barehanded for all that's worth, because and I had a customer that actually was like that. Their rubber gloves had not been dielectrically tested in 11 years. And when I looked at them, it's like, how have y'all not gotten anybody hurt wearing these? I don't understand this. Well, that's what you're here to teach us. Okay, well, I'm in the right place, obviously. So, you still see some crazy things out there that border on insanity. But, fortunately, most the people I work with are not that far out in left field.
Well, that brings us, actually, we went a bit overtime, so I'm going to probably call it a stop here. But this has been great, Stephen. Thanks a lot for coming on.
I've been having fun. I didn't even realize that much time had passed.
Time was flying. Maybe I got to switch this. We'll have you on next. We'll switch to one of those 3-hour podcasts.
And, you get me rocking and rolling on some of this. I'll get pretty evangelical. I'll give me a pulpit. I'll turn into a Baptist preacher. Talking about some of this, because it's so important, and I think you've got to be passionate about this. It's not, we all want to make a good living, but at the same time, it's, are we making a good living, helping our clients make a good living, and that's really, I think, what this is in a nutshell. So if you're not passionate about this, you probably need to find something else to do.
Yeah. Thanks so much.
Enjoyed it.